Welcome to your first geometry lesson. In the study of geometry, what we strive to do is build a logical system from which everything we say is true is proven using other statements we know to be true or statements that we agree are true without proof. When you build a mathematical system like geometry, we have to build at the beginning with the basics of geometry. The basics of geometry are points, lines, and something called planes, which are often represented as a rectangular like sheet of paper that extends forever in all directions, but a lot of geometers talk about it as a disk because that could also extend in all directions. Now these three things, point, line, and plane, we actually never define. We just have an intuitive sense for how they work. A point is a dot. Many dots in the same line form a line. And then many lines and dots exist on a plane. Those three terms we call the three undefined terms. Points. Points are denoted with a capital letter for their name. This would be read point A. Lines. Lines can be denoted with a cursive letter, L, like a lowercase cursive letter, could be R, could be T, whatever. Or 2 points on the line can be used to name the line in any order. You could name it AB or BA. You would read this line AB. You would read this line BA. And a plane can be given a capital letter name, often bolded or cursive. I've seen some pretty curly M's for planes. This one's a pretty bold M. Or it could be 3 points that are not on the same line, but on the same plane M. So we could call this plane ABC. Planes extend forever in all directions, but you can see here it's given this rectangular shape, but try to imagine it as an infinite sheet of paper. We live in an incredible world where you can just type into Google intersecting planes and get an image like this. So what you can see here, and this is a little harder, you have plane P down here, extending forever. You have plane C right here with the kind of vertical lines. You have plane D here, and then you have point. If I accentuate that, you've got a point here, B, and a point here, A. And you can see how those two planes intersect at a line. You can see how plane P and plane C intersect at a line. And that line goes on forever. You can see that plane D and plane P intersect at a line. You can see that this right here is a line that would go through plane P at a point. But you don't have to imagine those things because, again, Google can let you see them. Here are 3 planes that don't intersect. Here are 2 planes that don't intersect, but 1 plane that intersects them both. Here are 3 planes intersecting all at the same line. Here are 3 planes that all intersect each other, but not all in the same place. Here is 3 planes that intersect at a point. Now this first unit in geometry is about the basics. And we can't do the basics unless we know how to talk about geometry. So take a look at the following figure. You need to be able to name things in this figure. So take a second, pause the video, and see if you can name everything that's in this picture. All right. We have 2 planes. We have plane A and we have plane B. How do I know those are their names? Well, they're the bolded letters in the corner. They're somewhat different than just capital letters to denote the planes. We also have line PQ. And we have line K. Now there's lots of ways to name line PQ. You could have named it line MQ. You could have named it line QP. But K is the only way to name this line. There's no other point on it that we know. And then the other thing you may have seen are the points P, M, and Q. How do I know P here is referring to a point and not a plane? Well, I didn't write plane in front of it. How do I know that this K is not a point? Well, you don't really because I have bad handwriting, so let's make it a cursive K. We'll erase. I can't erase with this, so here we go. Cursive K, we'll do this. Good? So that looks very different than an M or a Q. I want to go back to this image. Let's talk about something that's happening in this image that we're going to talk about a lot. P, M, and Q are 3 points all on the same line. Here is your first geometry definition. The term collinear. Three or more points are collinear if they lie on the same line. So I told you we had 3 undefined terms: point, line, and plane. But now we can start building definitions. And here's one for you: collinear. See how it uses the terms point and line several times in the definition. So this is what we mean by undefined terms. We're never going to define point, but to define a word collinear, we need to have an intuitive sense for what they mean. I'm also going to talk about another definition, a definition called coplanar. And I bet you could fill that one in without me writing it. Coplanar. 4 or more points are coplanar if they lie on the same plane. And I need to get a better definition because it could be about points, but it could be points and or lines. So do you see this line here, PQ? Do you see this line, K? Do you see that those 2 lines are coplanar because they're both in plane A? Do you see if I was to put some line here that stayed in plane B, do you see how line K, and let's call this line T, do you see how line T and line K are in plane B and they're coplanar? So our 2 first definitions, collinear, coplanar. All right. The rest of these definitions I'll go a little bit faster through, requiring you to get the entire definition written down into your math definition notebook. One is the definition of a line segment. Often just called a segment. If you look at a line and you have 2 points on that line, I'm going to draw them in different colors. Say we have point A and point B. Then line segment AB is written this way. And notice there's no arrows here because now what we're talking about are all the points in between A and B, including A and B, but nothing else on that line. Good? The same segment is segment BA. We call A and B the endpoints. Another definition you're going to want to know is the definition of array. I'm going to introduce a different point, call it C. Array starts at one point but continues forever in the direction of a second. So we could have ray CB. Ray CB starts at C and goes forever in the direction of B. Notice that ray BC would look like that, and while they would overlap at all the points in between C and B, they would not be the same ray. So BC is a very different ray. Good? Notice though we write it with the endpoint of the ray first. Another ray that we might look at is ray AC. Starts at A, goes in forever the direction of C. That ray would be the same as ray AB. Starts at A, goes forever in the direction of B. Good? Take a look at ray CA and a look at ray CB. CA starts at C, goes in forever the direction of A. CB starts at C, goes in the direction of B forever. Notice that those two rays form a line and they're pointing in opposite directions. These are called opposite rays. If you're keeping track at home while you're watching this, you need to come up with at least 4 definitions. One for line segment or segment, one for endpoints, one for ray, which I didn't even write down, and one for opposite. The last term I want to talk about is something I've already said and something you have a sense of what it means already, and that is the term intersection. A lot of geometry is looking what happens when two lines intersect. Two lines intersect at a point. Good? Here's line S and line T. They intersect at point P. You've seen it before. I'm not going to be able to draw it as well, but I'll try here. Two planes intersect. Often those two planes will intersect at a line. Oh, I'm trying really hard here. Sorry, I kind of forgot to be talking. Oh. Good. Not the greatest picture, so I'll back it up to those previous slides. Planes, when they intersect with another, form a line. Take a look at that line right there. Take a look at these 3 lines. 1, 2, and then 3 back there. Take a look at these 3 intersecting at a point, but do you see that the 2 of them there form that line, 2 form this line, 2 form this line? Here they're all intersecting at the same line. Or they can be parallel and never intersect at all.